Now, this lesson focuses on one type of series, and it's called the infinite geometric series, and we're going to keep adding the terms together. Sometimes when people look at an infinite and they say, how can you find a sum if we don't know how many terms there are? But we're going to look at trends, and we're going to look at what's called partial sums and see if we can make a judgment based off that, and then I'm going to show you how to use the formula. So looking at our first example, we're going to look at partial sums. So if I continue the pattern, this one is 0.1 plus 0.01 plus 0.001 plus 0.0001 plus 0.00001, and I think from there you can kind of see the pattern, but what this creates actually is this is the equivalent to 0.1 repeating. So it's a series of ones, and 0.1 repeating is the fraction 1/9. And so we would say, because we got an actual number there, that this particular sequence, or series, sorry, would converge. Now look at this one, 10, 20, 30. So this is 10 plus 20 plus 30 plus 40 plus 50 plus 60. And what happens? We're just going to continue to add 10, and it is going to continue to get higher and higher, and this one diverges, which means there is no limit, and it continues to go on forever. So your formula then for infinite geometric series, we need to know a couple things. We need to know a sub 1 is the first term. We also know R is the common ratio. And each time we work with this, we're going to have to test the common ratio, because if the absolute value is less than 1, that means our common ratio has to be between 1 and -1. And if it is not, then our sum or series, sorry, will not converge because it doesn't have a sum. Okay, so some of these are going to be done by sigma notation. So let me look at the sigma for a minute and point out a couple things. So generally speaking, the number here is the common ratio. So what you're going to do is we're going to write down our formula. A sub 1 over 1 minus r, and we're going to find those. So the first thing we're going to do is we're going to check r. So the absolute value of 0.75, I want to know, is that less than 1? And the answer is yes. So the series converges. Okay, now what we need to do is now we're going to plug in and find our stuff. So S equals the first term. If I plug in 1, 1 minus 1 is a 0. So my first term is going to be 3. And then it's 1 minus 0.75. And I'm going to plug that into the calculator, and my sum is going to be 12. So this one converges. All right, so we look at the next one. Again, the common ratio, we're going to check it right away. So -1 should be less than pi over 2, which is less than 1. Remember, pi over 2 is 1.7 something. So this is not true. So there's no work required here. This diverges. And then there is no sum. So if your common ratio doesn't lie, then you don't have a sum within that interval. Okay, we look at this, we have to find the r. So what am I multiplying term to term here? R is equal to 1/2. And if I check it, 1/2 is between -1 and 1, so I know this converges. That's a check. So to find my sum, my first term is a 1, and then it's 1 minus 1/2, and so as these approach, my sum would be 2. Because what's happening is the fractions are going to get smaller and smaller and smaller, so what we're adding is not very significant, and that's why it converges at 2. Okay, last thing, we're going to write a repeating decimal for using an infinite geometric series. So this is 0.234 plus 0.000234. You add zeros based on how many repeats, and it keeps going. So this means the first term is the 0.234, and the R is 0.001. You can get that by dividing first term by second. And then we are going to find the sum by 0.234 divided by 1 minus 0.001, and then you end up with 26 over 111. And if you're having to write it out, yes, you can use your calculator to check, but I'm going to be looking at that work at that moment. Okay, here we go. Next one. So 0.57 plus 0.0057 plus 0.00057. That pattern continues. A sub 1 is 0.57. R this time is 0.01 because of 2 repeating decimals. And so then my sum is going to be 0.57 over 1 minus 0.01. And you put that in your calculator and you reduce 19 over 33.